All right, hello IB and welcome back. This is our last part of our lesson about descriptive statistics, and we're going to do an example. My whole lesson here is an example. We're going to take some data, some raw data, very similar to things that's presented in your textbook, although I'm going to be doing it slightly differently. I'll be using the same data on page 332 about the class catching the fishes, but I'm going to be doing it a little bit differently. I'm going to do some extra stuff in here and talk about some things the textbook doesn't talk about. All right, so here we go with our example. Now, there's going to be a lot of writing, no way of avoiding it, a lot of collecting data and writing data down. It's going to be easy to get lost here. So hang in on this. And what I want to look at is a fishing competition. Now, in this fishing competition, there were, let's say, 134 fish that were caught. And they were bought and they were weighed in, and we're going to check the weights and we're going to represent the data of the fishing competition here. So the raw data would be each of the different fish, more specifically the weights of the fish. How much did each of the fishes weigh? So the raw data would just be as the fishes come in, weighing them. We're going to use kilograms here, because after all this is the IB. And I'm going to represent the data in a statistical graph that we haven't talked about yet, but I'm sure that one is very familiar to you, called a stem and leaf. So we're going to have the stem and the corresponding leaves. Now, the way that this works, think about it as a category and a subcategory. So if I look at the weights of the fish that are coming in, and this is in kilograms, I could have something 0, and I'm going to put 8, 8, 9. What does that represent? 0.8 kilograms, another fish 0.8 kilograms, and then another fish 0.9 kilograms. So all of these fish weighed less than 1 kilogram. All the fish here represent at least 1 kilogram. So if I had a fish that was exactly 1 kilogram, I'd have a 0 here, and so on. So 9 kilograms, and then 10, 11, 12, and so on for the code. But I didn't have any fish that were in the 10s. Now in the 20s, I had a fish that was 21 kilograms, and then I had 3 fish that were 22, so 22, 22, and 22. And then I had a fish that was 23 kilograms, another one that was 24 kilograms, and 28 kilograms. Oh, I nearly put 28 there, but I just want to put the 8, just the leaf part. And then in the 30s of kilograms, I had a whole bunch of fish that were in the 30s. I had a 32 and a 33 kilogram fish. I had 3 of them that were 35s, represented by 3 5s here. And then I had a 36 kilogram fish and 2 of them that were 37. In the 40s, now we've got a lot of fish in the 40s here. I've got a 41 kilogram fish, and then I had 13 different fish that weighed 43 kilograms. 13 of them. So I'm going to have to put 13 3s here. All right, here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8. Whoops. 9, you know I was going to do that sooner or later. 10, 11, 12, 13. Oh, I did it there. 13. I did it again. That should just be a 3. So there's 13 fish that weighed 43 kilograms, and they're each represented by the 3s, the 13 3s here. Now, there was also 3 fish that were 34 kilograms. 1, 2, 3. There they are. There was a fish that was 45 kilograms. And then there was 4 of them that weighed 46 kilograms. 1, 2, 3, 4 of them. And then 4 that weighed 47 kilograms. 1, 2, 3, 4 of them. 3 of them weighed 48 kilograms. 1, 2, 3 of them. And then there were 5 of them that weighed 49 kilograms. 1, 2, 3, 4, 5. Stem and leaf. So 8, 8, 8, none in the 10s, 21, 22, 22, 22, 23, 24, 28, 32, 33, 35. That's the weight of all my fish. Now 5, I think, is going to be our modal class. A lot of the fish weighed in the 50 kilogram range. So a whole bunch of data we're going to write down here. Stay with me on this. There's 4 of them that weighed 51. 4. So 1, 2, 3, 4. 2 of them weighed 52. 1, 2. There's 2 of them that weighed 53. 1, 2. There's 4 of them that weighed 54. 1, 2, 3, 4. There's 6 of them that weighed 55. 1, 2, 3, 4, 5, 6. 5 of them weighed 56 kilograms. 1, 2, 3, 4, 5. 7 of them weighed 57. 1, 2, 3, 4, 5, 6, 7. Remember, each of these is a data point. Each of these represents a fish. There was 8 of them that weighed 58. 1, 2, 3, 4, 5, 6, 7, 8. And 9 of them weighed 59. Oh, can I fit that in here? So I want to put 9 nines in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to extend the table here. $56. There was a bunch that weighed 56 as well. There was 3 of them that weighed 60. 61, 61, 61. There was 3 of them that weighed 61. 3 of them that weighed 62. 3 of them that weighed 63. 5 of them weighed 64. 1, 2, 3, 4, 5. Don't turn off the video. Leave it, keep it running. If you don't get all this down, don't worry about it. Well, I'll give you all the numbers here in a moment. I want you just to look at this table. Where do we leave off? 64. And then there were 2 of them that were 65 kilograms each. There were 2 of them that were 66 kilograms each. 2 of them were 67 kilograms each. 4 of them 68. 1, 2, 3, and 4. And 1 of them was 69 kilograms. Extend the table. 70 kilograms. There were no 70 kilogram fish. 80 kilogram fish? No. 90 kilogram fish? Yes. There were 2 of them that were exactly 90 kilograms. There was a 91, a 92, a 94, 3 95 kilogram fishes, a 97, and the heaviest fish caught that day weighed 98 kilograms. He was the record fish that day. Phew. So we should have 134 fishes accounted for in our stem and leaf. Now this is a stem and leaf. The next thing we want to do is create a frequency polygon of this data, and then I'm not a frequency polygon, I'm sorry, a frequency table of the data, and then use the frequency table to create a histogram. So if you didn't catch all these numbers down, don't worry about it. You'll see it in the frequency tables. But this is what raw data would look like. This is kind of one way of organizing raw data. And in a moment, when we go to count to create our frequency table, we're going to have to count how many fishes in this table and how many in that table. All right, here we go. So the first frequency table I'm going to make, I want to look at the weight of the fish and the corresponding frequency. How many fish weighed in that category. And my classes that I'm going to choose, I'm going to choose from 0 to 25 kilograms, and then from 25 to 50 kilograms, and then from 50 to 75 kilograms, and then from 75 to 100 kilograms. Now notice, a fish can only be in one place at a time, so if the fish weighs 25 kilograms, it would be in this first table because of the bracket. Here, this would start after 25 kilograms, 25 to 50. And if the fish weighed 50, it's here. 51, it's going to be in here because of the open parenthesis. Is my data here, is my weight data, is that discrete or is it continuous? Well, I've got fish throughout here. I've got all fish that can be any number from 0 to 100. So this would be continuous data. We're creating it in tables where we've got a specific range, though. All right, so here's where I told you not to worry if you missed the numbers. I'm going to give you the numbers here. How many fish weighed between 0 and 25 kilograms? Well, 9 of them did. How many from more than 25 up to and including 50? 43 of them did. From 50 up to 75, including 75, 72. That's where we were writing all those crazy numbers. And then from 75 to 100, only 10. So now I'm going to create a histogram of this data. My x-axis, so here comes the histogram. My x-axis is going to represent my classes. So I'm going to have from 0 to 25 and 50 and 75 and 100. My frequency is represented here. So these are the weights, and this is my frequency, how many fish weighed that. And as you can see, my frequency goes up to 72. So let's see, if I go 25, 50, 75 fishes. 5, 10, 15, 20, 25. 5, 10, 15, 20, 50. 5, 10, 15, 20. And of course, if this was a nice project or something, I think I would make a much nicer graph of this. All right, so in the first category, 0 to 25, there were 9. So my first, a little bit short of my 10 mark, there was only 9 here. Between 25 and 50, there was 43. So there's 45. So it's going to go up right about here-ish. And there were 43 in this category. Between 50 and 75, 72. So clearly, the way I've got the classes now, this would be, without a doubt, the modal class. And then 10 here. So here's my first attempt at a histogram. And I don't really think it shows the data very well. The small number of classes, I've only got 4 classes here, and they've all got a very wide range in the classes. So it doesn't really give me a good idea on the distribution. It makes it very difficult. Clearly, most of the fishes seem to be happening in here, but I really don't see a lot of variety here. I don't see much spread. It's not very descriptive of what I want. So how can we make the data better fit? Well, we're going to create another frequency table, and we're going to change our classes here. And again, don't worry about counting. I've got all the numbers, so I can give you the numbers if you missed all of that from before. So now we're going to look at weight, frequency, and I'm going to change my classes. So in my first class, I noticed there wasn't many between 0 and 30. So in my first class, I'm going to go from 0 to 30, including 30, but not 0. And then I'm going to go from 30 to 40, including 40. Now this is a different range here, isn't it? 0 to 30, 30 to 40. And then I start getting a lot of ones in 40s. So my next one, I'm going to go from 40 to 45, including 45. And then I'm going to go from 45 to 50, including 50. And then from 50 to 55, including 55, but I'm not including 50, I included it over here. And then there was a whole bunch of fishes. In the 50s, it got kind of crazy here. So my next class, I'm going to go from 55 to 57. And then from 57 to 59. And then from 59 to 61. 61 to 65. Notice I'm switching up the classes again as it kind of stretches out here a little bit. 61 to 65. 65 to 70. And then finally I'm going to go from 70 up to 100. So not all of these classes have the same width. But that's okay. We're going to represent the different widths in the frequency, in the histogram here. All right, so the next point would be a lot of work. We'd have to go back. How many fish are greater than 0 and less than or equal to 30? There were 10 of them. How many were greater than 30 and less than or equal to 40? There were 8 of those. Greater than 40, less than or equal to 45, there were 20 fishes. Greater than 45, less than or equal to 50, 16 fishes. Greater than 50, less than or equal to 55, 12 fishes. Greater than 55, less than or equal to 57, there were 11 fishes. Greater than 57, less than or equal to 59, 15 fishes. Greater than 59, less than or equal to 61, there were 9 fishes. Greater than 61, less than or equal to 65, there were 14 fishes. Greater than 65, but less than or equal to 70, 11 fishes. And greater than 70, but less than 100, there were 10 fishes. So look at my frequency. My frequency numbers are a lot closer. It's not such a crazy variation as the first time, going from 90 to 72. These numbers are all fairly close to each other, but the widths are very different. Here I used a class width of 30 kilograms, where over here I'm using 2 kilograms, 2 kilograms. We're going to represent that in our new histogram. All right, so now let's create a corresponding histogram of this data. Now on my x-axis are going to be all of these classes. And I know that my classes have different widths, but I want to go from 0 to 100 here, so I'm going to go 0 and make that 100. Halfway between them, right about there, should be 50. This would be 25 and 75. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Whoops. Oh dear, I made a mistake there. 75, 80, 85, 90, 95, 100. I need to spread that out a little bit there. That's not a very good marking, is it? All right, and as I look at my different classes, in my first class, I need my vertical axis here. This is my frequency, so this is the weight of the fishes, and this is my frequency. I notice I'm going as high as, what's my biggest number here? 20? So if I call this 20, 10, 5, 15. Now my first class was 0 to 30, and there was 10 of those. So from 0 to 30, which is right here, there was 10 of those between 0 and 30. So this is my first class, 0 to 30, and there was 10 of them. So I like to put the numbers up here. I know I'm going to have a bit of a problem when it's very narrow. The next class went only from 30 to 40. So 30 to 40, so my next class is only going to be this wide right here, and there was 8 of those. My next class went from 40 to 45, even more narrower, but that was my modal class at this point, so I want to go as high as 20 here. It'd be nice to have a ruler, but there we go. And this had 20. And then from 45 to 50, there were 16. So let's say right about here is 16. Now let me pause for a moment. In a histogram, each of the rectangles has to represent the class. The area has to represent the class. So there were 10 between 0 and 25. It's much wider here because it's a much bigger class here than between 30 and 40, and which is even wider than between 45 and 55. So here are my classes, and then the frequency, how many times it occurred. All right, so let's finish the polygon now. The next class goes from 50 to 55. and there were 12 of those between 50 and 55. So 12, let's say 12 is right about here. Um, 12. My next class goes from 55 to 57, even more narrow. 55 to 57, and there was 11 of those. So the next class is even smaller and narrower. I'm having a hard time writing the numbers up there. In this class, from 55 to 57, there was 11. The next class, 57 to 59, and 57 to 59, there was 15 of these. So it's going to go up here to 15. Very narrow class all the way down. And 57 to 59, there was 15 here. And it's important that these classes are narrow because it's narrow here. 59 to 61, there was 9 of them. So 9. The numbers up there are really not part of it, not necessary, but I like them because my table's not really that good and my scaling isn't that good. The next class was 61 to 65, a little bit bigger than this class, right? A little bit bigger than these classes. 61 to 65, oh, this is where I messed up, wasn't it? And 61 to 65, there were 14 of them in this group. So a little bit bigger. My scaling down here is a little bit messed up, so please ignore that. And there were 14 in this group. The next class is 65 to 70, and there was 11 of those. So let's say that's 70 there. Notice the class here. And then my final class went from 70 all the way to 100, and there was 10. Now this histogram is a lot more descriptive. Clearly we can see where the modal class is between these two. I mean, we actually spotted it from our frequency table, 40 to 45. But there might have been a lot of other fishes other places, but just in this small range right here, clearly that's the modal class. The widths of the classes vary. Why did I choose these widths? Well, I wanted the numbers to be a little bit more reasonable. I wanted to be a little bit closer so we could compare them. Now take a look at this. Do you think this is a better representation than the previous histogram? Notice that it does emphasize that the area is proportional to the frequency. We've got the fixed heights of the rectangles and the frequency, how many, the heights and how many occurred there. All right, so that's it. That's the end of 5.2. So now at this point, I want you to go ahead and you're going to do exercise E, 5.E. Just in case you've got this off and you're just watching me. Do 5E. No, that's not 5E factorial, but go ahead and do exercise 5E, and I will talk to you again soon. Bye-bye.